All right. So we're going to start off by reviewing how to simplify fractions, because simplifying fractions are going to be something when we're solving proportional relationships that if you know how to do this well, it's going to make your job a lot easier. And then it's just one of those skills that we need to know how to do as seventh graders in general. So when we're trying to simplify a fraction, we have to find the greatest common factor between the two numbers. So yeah, I know that you can probably mental math it, a lot of you guys, 6, and you know that, but we're going to go through the steps and how you do it. So when you get a fraction that's not that obvious, you know what you're doing. So first of all, what are the numbers that we multiply to get 6? So we'll go through, we'll usually start off with 2. So if we divide 6 by 2, what is that? 3, right? What's 6 divided by 3? 2. Can we divide 6 by 4? No. Can we divide it by 5? Can we divide it by 6? What do we get? 1, right? And then we're going to do the factors of 12. What's 12 divided by 2? 6. 12 divided by 3? 4. What's 12 divided by 4? What's 12 divided by 4? 7th graders, what's 12 divided by 4? 3. Thank you. Can we divide 12 evenly by 5? No. How about 6? Yes. 6, right? Equals. 12 divided by 6 equals? 2. So what was the greatest common factor here? 6, right? 6 divided by 6 is 1. And then 12 divided by 6 is? So if we simplify the fraction 6/12, it's equivalent or equals 1/2. Now, the common factors that I normally check, like as a shortcut, is I usually check for 2, 3, 5, and 7, right? 2, 3, 5, and 7. So if you're confused about the factors, I look and I say, can both these numbers be divided by 2? That's a good starting point, right? Or you can say, hey, can both of these numbers be divided by 3? If not 3, then I move to 5. If they're both multiples of 10 or 5, chances are I can divide it by 5, right? Next, solve each proportion. So we've gone over this a couple days this week. Yesterday, I was pretty passionate about how you guys needed to know how to do this. Because I realize there's certain problems that you're going to know how to do it and you're just going to say, you know, we just multiply and divide. But there's certain problems that if you have a proportion and you know how to set up and enter into a proportion, it's going to make your lives easier. So here we're going to cross multiply. What's 12 times y?
12y.
12y, thank you. And then we need an equal sign. What's 4 times 9? 36. You should be copying this down if you're not. Next step, we have a one-step equation. How do we get this y by itself? Divide by what?
12.
We're going to divide both sides of the equation by 12. Y equals 3. Now we're going to check it. We can check it by plugging or substituting the 3 back in for the y. And then how do we check to see if two ratios are equivalent? Not quite. What? What kind of multiplication? Cross multiply, thank you. What's 3 times 12? 36. What's 4 times 9? 36. Are these equivalent? Yes. Let's talk about another way. So we'll use this same proportion. 4 twelfths equals 3 over 9. What's another way of us checking to see if these ratios are equivalent? I gave you another way. Simplifying. So let's try and simplify these. We just went through the process of simplifying fractions. What's the greatest common factor between 3 and 9? 3. I can divide by 3. Divide by 3 equals 3 divided by 3 is 1. 9 divided by 3 is 3. Now, what's the greatest common factor between 4 and 12?
3.
Ooh, can 4 be divided by 3? What's the greatest common factor?
4.
4. So we'll Divide by 4. Divide by 4. What's 4 divided by 4? 1. What's 12 divided by 4? 3. So we cross multiplied. We determined it was equivalent. We simplified the fractions. We determined it was equivalent. There's one last way I showed you to determine if they're equivalent, which is? I gave you one more way to determine if these were equivalent. What was that other way? We could convert these to decimals. So I can convert these fractions into decimals by dividing. This line in the fraction means to divide. This means 4 divided by 12. Or we use a little trick. We say the top dog goes inside the house. How many times does 12 go into 4? 0, right? We need a decimal. And I always like to add 3 zeros in case we need the space. How many times does 12 go into 40? 3 times. 3 times 12 is 36. Drop the 4. How many times does 12 go into 40? 3. So it looks like this is going to be 0.3 repeating, or 3/10 repeating. Here, over here, 3/9. Top dog goes in the house. So we're going to do 9 into 3. Can 9 go into 3? We need a 0. I'm going to add 3 zeros after my decimal. How many times does 9 go into 30? 3. This is going to be 3 repeating. Are these equivalent? Yes. So 3 ways of determining equivalency. 1, we can cross multiply, which we did. 2, we can check to see if the ratios, if we simplify them, if they're equivalent. And then 3, we can convert them into decimals. So we said that we were going to solve proportions, and we just did that. Now we're going to calculate unit rates. So unit rate says to calculate each unit rate. And for here we have $240 for 4 days. Now before we get into solving this, we're going to talk about what unit rate means. Does somebody remember we talked about shopping at the grocery store? And I gave you a couple of examples of what unit rate was. Who can tell me in your own words what unit rate is?
The amount of one thing is worth.
Perfect. The amount one thing is worth. So you're on the right track, and I like the description. Does anybody want to add on to that?
Maybe like the total that you get per one.
The total that you get per one? On the right track? Right? Anybody else? It's a rate where we compare one unit to one of the other unit. When we go to grocery store and we buy fruit, how do they sell us fruit? So cost per pound. How many pounds are we talking about?
1.
Per 1 pound, right? So grapes might be like $4 per pound. When you buy gas, how do we buy gas?
Per gallon.
Per gallon, right? They charge you dollars per gallon. In this problem here, what are the 2 units that we're talking about?
240.
Units. We're not talking about numbers. What are the units?
Money.
Money in days. So our first step when we're doing a unit rate problem is we want to write the units. So we're going to say dollars per day. And then from there we can fill it in. So how many dollars were there?
240.
240. How many days?
4.
4 days. Notice how I'm labeling the units. It's very important for unit rates, or else it's just a regular number, right? This is a unit rate. Now unit rates, we say we want to know how many per one. Say how many per one?
How many per one?
If you don't have this written down already on your paper, I want you to write unit rate and then write how many per 1 unit, right? Write it down. How many per 1 unit? And then from there, all we're going to do is we can think of this in 2 ways. We can simplify this ratio, or we can just say that we're going to divide. So whichever one you prefer, but here I'm going to divide, because we always want to have a denominator of 1. And so in order to figure that out, we're going to divide. What's 240 divided by 4? 4 goes into 2, 0 times. 4 goes into 24. 6 times. 4 goes into 0, 0 times. So what does this mean? Let's say this was Nadia, and this was the amount of money that she makes. What does this tell us about the money?
$60 for 1 1 day.
Awesome. She made $60 per day. Right? So in order to calculate unit rates, you're just going to simplify. And we're trying to find out how many per one. Questions on that? All right. Last but not least, we've done this already, but we're going to calculate rate of change. And those of you who did the homework last week, rate of change, copy that down. And then I want you to write change in Y over change in X. That little symbol, that little triangle looking thing is the Greek symbol delta, meaning change. So you don't even have to write the word change. You can just, in math, we like to use symbols. Because this symbol, this means delta, or this means change. It doesn't matter what language you speak in math, it's always going to be this symbol, right? So you could speak Spanish, Russian, Japanese, Slovakian, I don't know if that's a language, right? So change in Y over the change in X. Now we're going to have to calculate the change in Y over change in X. Well, first of all, do we know what here is the Y and what here is the X?
Yes.
Somebody tell me how and why. How do we know? How do we know which one is the Y and which one is the X?
Y is right. The Y is time and the X is moment.
So what's your reasoning behind that?
Because usually the lower number goes on top and the bigger number goes on the bottom.
I'm glad you said that. That's a big misconception. When it comes to ratios and rates, it doesn't matter which one is the bigger number on top or bottom, right? It just depends on the data that we have.
The time spent mowing is X because it's the independent value.
Awesome. What she said is X is the independent value. We're going to come back to those concepts. X is the independent, Y is the dependent. We're going to come back to that. You should have learned it in 6th grade, but you probably need a refresher. Shh. Thank you. Now, we talked about calculating the change. How much is this changing by going from 10 to 30? Plus what? How much is it changing by?
20.
Plus 20. How much is it changing by from 30 to 50?
20.
Plus 20. How much is it changing by here?
20.
Plus 20. And then for the time spent mowing, how much is this changing by?
2.
Plus 2, right? Notice how I'm putting the plus 2 or the plus 20. Because some problems that you're going to get are going to be going backwards. So instead of adding, they're going to be subtracting. And that's going to make your rate of change into a negative rate of change, right? So here, plus 2, 5 to 7, plus 2. So now we're going to take our change in Y. We said the money earned was Y. What was the change in Y?
Plus 20.
The change in Y was plus 20. What was the change in time?
Plus 2.
Thank you. So let's look at this. Our change in our Y, or our money, was plus 20. So I put that into my ratio, or my rate. The change in our X was plus 2, so I put it where the change in X goes. Can I simplify this?
Yes.
The greatest common factor between these two fractions, or these two, what's the greatest common factor? 2. So 20 divided by 2 is?
10.
Bless you. 2 divided by 2 is?
1.
What does this mean? So what is this? Give me the story about this 10 over 1.
10 is the money earned, 1 is the time spent.
So tell me in like a sentence.
$10 per day.
Awesome. Per day?
Per law.
Per hour.
Thank you. $10 per hour. That's our rate of change here. So let's rewind to see what we did. We determined that time spent mowing was our independent value, our X, and we determined that our money earned was dependent on the time, so this was the Y. We figured out how much the Y was changing by. It was increasing by 20. We figured out how much time was spent mowing, how much it was increasing by. It was increasing by 2. We put them into a ratio. We simplified the ratio and we determined that we were making $10 an hour mowing lawns. Now let's discuss how and why we understand the dependent and independent variables. So the little trick that I always give my students, when you break up with somebody, what do you call that person? Your ex, right? And that person, when you break up with them, when you break up with that person, they can no longer depend on you, so they become independent, right? So when you break up with someone, they become your ex, and they become what? Independent, right? So the ex is always what? Independent, right? And then we don't need a trick to determine the Y, because if you know the X is independent, then you know that the Y is automatically dependent, right? So again, you break up with somebody, they become your X, and then your X is independent. Now, one thing, and I want you to write this, is time is always independent. Write it down. Time is always independent. Time is always independent. Now, let's talk about why time is always independent. When you go to sleep, does the clock stop?
No.
No, right? The earth keeps spinning even though you're sleeping. If you're in school, does the clock stop?
No.
No, right? So time keeps going. Time doesn't change for anyone. So no matter what's happening, the time is going. So time is always, and at least in the 7th grade, it's going to always be independent, right? Say time is independent,
Time is independent.
right? Because time waits for no one. Now, so we said today that we were going to calculate unit rates. We calculated unit rates. We determined constant rates of change in Y over the change in X. We solved proportions by cross multiplying. And we also talked about simplifying ratios in order to determine if they're equivalent. And we also converted them into decimals. And then we talked about independent variables. And we said if you break it with somebody, they become your what? And your X is always independent. Well, at least most of the time they are. Sometimes they're really needy and they still depend on you.